back to that stuff that we did yesterday, and we'll finish up that at least part of the back that we couldn't last time. Anybody need a copy of yesterday's stuff so I can get that so you're ready once we get there?
Yeah, I think I might have left mine here. Maybe see an extra paper.
No, this one. No.
I might have put it in the wrong folder or something. Right.
Oh, there you go. Anybody else need something from yesterday? All good. Okay, cool. I've got them here just in case you're looking through and you can't find them later. But first, before we can actually like answer number 9, we have to develop something to help get us there. So I think we should probably just start in our notes and just make a small little adjustment to this nice little formula that we have right there. It's okay. Good to see you guys. Just make a quick, small little adjustment to that. And I think we're probably at a point where we can even make that change. Like we can figure out how to develop what's different about it. So the last thing we'll do is we'll do number 9. That'll be at like 1:45 maybe. So jump into your notes for now and get yourself somewhere. I mean, so eventually there's going to be 3 formulas. Like this is super in general. Then we get more specific and then even more specific. But I want to develop something that has to do with what's called compound interest, which is the actual way that banks are going to pay you money, which is good to know, right? And it's also the way that they decide how to charge you, like if you take out like a student loan or an auto loan or a house loan, right, called a mortgage. So it works in both ways. It helps us as consumers, the ones that are trying to make money, but it also helps the banks, for sure, in charging you a little extra. And of course, banks' loan rates are always going to be higher than their interest rates for like savings accounts and stuff like that. Take a guess. My savings account. You don't have to write this down. I just wanted to write it down. Like my actual savings account that I have, where like all my money that's not invested. How much interest do you think I make? Take a guess. What my actual bank account interest rate is? 2%? 7%? 3? 2.5? 10%?
I know I heard you talking about it. I forgot. Oh.
0.02%. This year, I have made 15 cents. That's it. I looked at it. 15 cents is how much I've made on like 7 grand sitting in my bank account. Like 7 grand sitting in a savings account, I have 15 cents added to it. Great. Okay. Savings accounts is not how you make money on your money. Okay. Because there's no risk here, right? There's no risk in me putting money into a savings account. The bank cannot take it. I can't lose it. Even if the bank goes under, right? They get like bankruptcy or fraud or whatever, like bank rob, doesn't matter. I am covered up to $250,000. And so is everybody in the country. Every single person is covered up to $250,000. So I'm good, but I ain't making much. Which is why, yeah, I've got 7 grand in a savings account. I've got 25 grand invested. And I've got a house that has a loan that's like $280,000. Right? You're gonna have to take some risks in this world if you want to try to make some money on your money. Now, to develop this, I'm just gonna call it AFT again. It's amount after time. There's not much that you're gonna see that's super different. The thing about this whole compound interest thing is they're gonna like give us an annual interest rate. Okay, like make 5%, make 10%, make 0.02%. Right? But they're gonna pay us more frequently than that, which is the reality of life, right? I've got an interest rate that's like over the whole year, but I get paid more often than that. I get paid monthly or weekly or daily or hourly or quarterly or whatever, right? I'm gonna get paid more frequently than that. Didn't think myself. So what I think I want to do to help us come up with this, I think it's easiest if I just like give us an example that makes sense, and then we'll develop the like tiny differences between regular percent growth and decay and just a slightly more specific compound interest formula that's really close. They're all really close. Okay, to help you figure this out, I'm going to give us an example with easy numbers to do what we're going to do. Let's say, so close one. We'll eventually do like 2 or 3, and then we'll do number 9. Oh, so somebody wants okay. Let's say, easy round number to start with. Let's say we start with $100, and we put it in an account, and that account earns 12% annual interest rate. Yeah, it's got a 12% annual interest rate. So think about that for a second. All right, so we're $100. By the end of the year, if it was just regular percent growth and decay, I'd make 12% of my $100. So how much interest would you earn? $100, 12%, $12. So what would you have total? $112, right? And if I didn't compound the interest, if they didn't pay me out more frequently than that, that's exactly what I have. I'd have 112, right? But here's the thing. Banks are going to pay you at least monthly. So let's do that. Let's say that our interest is compounded monthly. How many months are there in a year? 12. Okay, cool. So we're going to need that number. So think about it. Let's see what changes make sense to this. Okay. First thing I have to equal sign is principal. Does it matter what interest rate I have or how often I'm getting paid? Like I walk in the door with a $100 bill and I drop it in the teller's hands. Does it matter what bank account I'm putting it in, or is it just $100? What do you think? Is the starting amount affected by whatever I put it into, or did I always just start with $100? Do you think that this should change? The P. It's the starting amount. Don't do a thing. Just P. Principal. All right. Start with $100. Now I want the 1 for sure, because that kind of takes care of me adding the original 100 back in. So just the number 1 again. All right, now the plus or minus. Never going to go down. I'm making money. So I can keep this simple and always just add whatever my rate is. But here's the thing. You're getting paid 12%, but that's like the whole year. I'm going to make 12%. But I'm getting paid monthly. So how much interest do you think you're going to make every month? 12% for the whole year, but you're getting paid 12 times per year. 1%. Okay. So think about that. All right. Now don't change this. All right. What if it was like 24%? How much are you getting paid per month? 2%. Okay. What if it was 36%? So what are you doing to that interest rate because we're getting paid so much more often than that? Like division. And what we're dividing by is like the number of times we compounded, right? Divide by 12, divide by 12, divide by 12 every time. What we're going to have to do is we're going to have to take this R and divide. Because I can't get 12% every month. That would be way more than 12% annual interest rate. Right? That'd be huge. I'd get a ton of money. So they're going to take that rate, they're going to chop it up even. And what they're going to do, so this is the only thing that's really different is what I'm about to kind of write right here. We're going to have to divide by the number of times we compound interest per year. Right? So if it's monthly, let's just divide by 12. What if it was daily. What do you think we divide by? 365, right? Now, realistically, there's 365.25 days in a year, right? Because every 4 years we add February 29th. So we'll just keep it simple, divide by 365. What if it said weekly? How many weeks are there in a year? 52, nice. That's a harder question to people realize. 52 weeks in a year. Now, the easy way to remember that, take 365, divide by 7. It's like 52 change. Yeah, so it's not exactly 52, just like it's not exactly 365, but we'll just call it 52. What if it was like quarterly? How many quarters are there in a year? 3 months is the length of a quarter, so 4 of them, right? How many quarters in a dollar? 4, right? So if they say quarterly, we'll just divide by 4. Semi-annually, twice, right? What about yearly? How many years are there in 1 year? 1. Yeah, so we just divide by 1. Let's put the change. So we gotta always divide this rate up. Okay. Now, the number of times we compound interest per year, it's a number. Fine. I'm just gonna put n for the number. Okay, so it's always plus, but that rate just gets chopped up. Okay, cool. So now I'm going to change t here in a second, but I want to start building this, right? A of t equals, okay, principal, nice, 100 times 1 plus, what's 12% as a decimal? Nice, right? 12 cents, right? $0 and 12 cents is a good mindset to have there. So what do you think I should divide by if we're compounding monthly? Well, the number of times that's going to happen. Okay? But think about that. I'm getting paid 12 times per year now. And so if t is 1, how many times did I get paid? 12. If t is 2 years, how many times do we get paid? 24 times. If t is 5 years and we're getting paid monthly, how many times do you get paid? And so what are you doing in your head with the 12 and the t? You're doing what? Multiplying. Here's the thing. If I'm going to divide up my rate and chop it up into all those pieces, I better get paid that much more often. Right? So when we think about the exponent having to adjust with that, all right, if I'm going to divide my r up into tiny little pieces, well, I better get paid that much more often. And that's it. Okay, that is the compound interest. Exactly percent growth and decay. We just divide up r into those little pieces, but we're going to get paid that many more times. Because that's all the exponent is how many times we get paid, right? When it was just years, okay, I just multiply it by 5 years or 10 years, like I'll put that up in the exponent. Now it's going to be like times 12 for monthly or times 365 for daily. Right? Imagine money getting dropped into your bank account every single day. Now, not a lot, right? Because taking an interest rate and dividing it by 365, that number is really, really small, but you're going to get paid over and over and over again. So up in the exponent here, it's not just t anymore, and in this case, it's 12 t. Okay, this n right here and this n right here are just the same number. Okay, that's why I'm using the same letter. I'm going to divide up my rate into whatever little pieces I need to, but I want to get paid that much more often. So call that like part A, like writing a model in terms of t. Now let's say something like, all right, how much money is in the account after, I don't know, let's say like 3 years. Well, no, you know what? Let's keep it simple. Let's just go 1 year. Right? Because we thought, all right, I should be sitting at $112. Let's see what happens, what the difference is by compounding that interest over and over. Right? So now we can do A of whatever t is, which is just 1, right? 1 year. I don't have to worry about the 12. It's already in there. It'll take care of that compounding for me. 1 plus 0.12 over 12. I don't even have to divide. I can just leave it. I'll have the calculator do all the work. Up here is just going to be 12 times 1, which you can write as just 12, or you can write 12 times 1. Let's see what we get. Calculator all the way. You're going to be doing some calculations, so take out whatever calculator you're going to use. Because you want to make sure you can type this stuff in well. What's nice about the Calculate 84 app is once you get into the exponent, it just keeps you up there so you can type whatever you need to. And then you just kind of write error out once you're done. All right, so jump in. Calc 84. Type it in exactly as you would read it out loud. No, I don't want to upgrade. 100. Parentheses. 1 plus 0.12 divided by 12. Exactly just like that. To the power of 12 times 1, this is 12. Now, if it was just like once a year, I get my $112. Now, swimming in the money, $112.68. Right, so there's like 682, right? So it doesn't go. Now, I know 68 cents is not much to write home about. But listen, if you're going to pay me more just by leaving my money in the account, I'll take it. I will take it for sure. Now, I rounded, so I had a little squiggly equal sign in. But what's nice about that is, yeah, okay, so I really got like 1% all the time. So, all right, first month, they pay me $1, right? 1% on my 100, there's $1. And that dollar goes in. The bank gives me the dollar and it sits there. And now when I get my 1% the next month, now I'm not getting $1. I'm getting $1.10. I'm getting that extra percent on that extra dollar that they gave me. That's compounding interest. Get paid more often. And if you can take advantage of that by finding things that pay you more frequently, right? As this goes up, yeah, I know this fraction is going to go down, but this exponent is huge. Huge. Get paid daily, get paid hourly, get paid every minute, every second. I know it's not going to be much, but that adds up over a short period of time. All right, cool. Let's do now. And then we'll just do number 9. Because once you know what to do, it's the same thing over and over again. It's just the same formula. Just drop it in. Just got to work with the n a little bit. Just to make it work for you. So call this one number 2 again. 2. I don't know. Bryson, what do you want to start with? How much money should we start with? Pick a number.
170.
170. Nice. $170. Okay. Caden, give us an interest rate that's just not 12. Give us something else. Go bigger, smaller, whatever you want. 72%? I like it. Find me that bank account. 72% annual interest rate. Okay. Brendan, how often should we get paid? Monthly, daily, weekly, quarterly, whatever. Every month? Let's switch it up because we did month last time. Weekly, cool. So let's compound. So compounded weekly. Beautiful. That's all the setup I need. What we'll do first, let's write a model in terms of t. Okay. Just as it's always good to just start with a of t, see what we got. Right, because that's kind of what we did here, right? Write a model in terms of t, so we'll have t still in it. All right, so what goes first? 170, our principal view, right? And I don't put the dollar sign in the formula. I just save it for the end once I'm done. Okay, parentheses, so p times 1, just the number 1, plus. All right, on top, our interest rate, but as a decimal. I just don't have a percent button, so I got to switch it up. 72%. Nice, 72 cents. 0.72. But because it's compounded interest, and seriously, if you don't see this word, if you don't see the word compound, you're not using this formula. It's got to say compounded, and it's got to tell you how often. Now, it's weekly, so what number should we put on the bottom? 52. 52 weeks in a year. Again, it's like 52 and change, but we just put 52. But up in the exponent goes that same 52 with a t being multiplied. Now put the dot in between or not. 52 times t or 52t means the same thing. There it is. There's our model, no matter how far out they want us to go. Let's do a couple of them. Let's eventually do A, B, and C. Let's ask the question though. How much money is in the account after, I don't know, hold a little there. Give us a number of years. 4 years? Sweet. After 4 years. Let's see how much we're going to make. Now, 72% is a lot, and we get it compounded often, and we're going to leave it in for 4 years. So that's A of 4. You don't have to worry about doing the multiplying. Say, oh, but it's 4 and 52. No, that's in the formula itself. This is just t, so we just match that up. I'm going to write it down, make it look nice. I'm not even going to multiply it out, though. I'm just literally just going to put 52 times 4. I'll let the calculator do it. Pretty good chance I got a round, though, with all these decimals and all this exponents. Let's see what's going on. 170. 72% for 4 years. This is going to be big. Man, I can't even guess. Let's see. It's at least $500. At least 500. Let's see. 170. Oh, where'd you go? Come back. 170. Keep wanting me to upgrade. It's not happening. 0.72 divided by 52 to the power of 52. It's not 0.4. It's times 4. Whoa. Really? Wow. I told you, find me this account, man. I'm in. I am in. $2,969.18. On $170, you turn in almost $3,000 in 4 years. I'm in. So 72% is not something you're going to find without taking the risk of losing it all. Okay. So that would have to be an investment into something that bears some risk. Stocks and things like that. Now, I know a little bit about it. I mean, I'm like I told you, like I've got $7,000 in savings account. I've got $25,000 invested. And so I'm up, let's see, because it came from Chase. So after college, like I got a math degree, I had no idea what to do with it. And so I went to work in finance. And when you work for a private corporation, you guys know what a 401k is? You've heard of that? Right? It's a retirement account that's sponsored by your employer that you buy into, right? Money comes out of my check before it gets taxed, which is why it's nice. Goes into a retirement account, and I can invest it in whatever I want. And a lot of employers, especially bigger ones, will match that contribution. Like they'll pay into it for you as well. So if I put $500 in, they'll put $500 in too, which is kind of nice. So I turned $16,000 into $25,000 in 8 years. So that's pretty good. But if I showed it to you, you can see. I'll pull it up. I'll show you what it looks like. You can see how much up and down there is to do it. Because I actually kept it in Chase. When I left Chase, it went from a 401k. I can't keep it if I don't work for the company anymore, but I can't keep the money. I take it out of the 401k and I roll it into an individual retirement account. It's called an IRA, individual retirement account. And then I can invest in whatever I want without, obviously the bank is not going to match it anymore if I'm not working for them. If I'm not making them money, they're not just going to hand money out. Come on. I want to show it to you. There it is. But it is under my control. But it is my money, but I can't touch it yet. I have to turn 55 before I can touch that money without penalty. Okay, that's why it's called a retirement account. There's actually laws in place to keep people from taking money out. Now, I can take it out if I wanted to, but I have to pay a 10% penalty on whatever I took out. So I took out $1,000. Really, I'd only get $900. I'd have to pay $100 just to touch the money, which is great. But I get it. It is what it is. Way more in my savings account than I have in my checking account. But I am a little extra flush because the tax money came through and my stimmy came through. I'll take it. We got $25,000 sitting in my retirement account right now, all from Chase, which is cool. See if I can do this. Attach to everything here now. Okay. Here's the last year. That's my investments. I'll show folks at home. That's my investment over the last year. So mostly up, little ups and downs though, for sure. Okay. There's the last 3 years. Still up for sure. It's all stocks. Yeah. So what I'm invested in is pretty aggressive in terms of what I've chosen to go after because I'm young. You invest aggressively early, and then you start to play it safer and safer as you grow old. Like once I hit 40, I'll probably chill out a little bit. Once I hit 50, I'll really chill out. And I'll invest in something a lot safer, like less return, but less risk. Because this is very common, right? That kind of up and down in the stock market is very, very common. What do you think that little dip right there is where it fell to its less, at least for COVID, right? Market crash big time, right? Let's check 5 years. There you go. It's 5 years, still going up.
What's that one?
The first step at the bottom, that was March 2017. That's a good question. I don't know. I'm not sure. So things that affect the market aren't always obvious, like COVID or back 2008, 2009 with the big market crash or whatever. But yeah, April 2016 is when apparently this fund started that I got in there. I had 16 grand right there, and here I am sitting at 25 grand. So the thing that I'm invested in is 100% stocks, but it's not like I bought like all Apple or all Gatorade or all Nike or whatever. I'm invested in what's called a mutual fund, which is like one thing you can invest in that is actually invested in like thousands of other companies all at once. So I've got like little pieces of everything so that the ups and downs aren't as big. The type of companies that I chose to invest in, it's called the U.S. Large Cap Fund. So U.S. companies that have large capital, big companies, which are usually safer from a lot of those ups and downs. So it's a risky investment into safer companies, which is why, although I have had ups and downs, it hasn't been as dramatic as if I like just invested in one company versus another. Now, I'll tell you one thing, if you're thinking about the future, there was something that in 2010 was worth $5, and now in 2021, that $5 is worth $200,000. One of them specifically, the first one. You invested $5 into Bitcoin in 2010, you would have $200,000 in Bitcoin. So I've got some, but the problem is I invested in Bitcoin in 2018 when $5 worth of Bitcoin was worth like 100,000. So my small investment, I dropped $1,000 on Bitcoin or something. It's worth like $2 grand now. I'll take it, sure. But it's just sitting in a crypto wallet, hoping that it just keeps exploding. I even got my parents to invest. They invested 10 grand into a different cryptocurrency, but that's a very volatile market, very volatile that I don't know enough about to really play it big. Yeah.
So like, when we all turn like 25,
yeah.
Like, what are you do worth it to invest in Bitcoin by then?
The hard part is that like past performance is no indication of future value, right? So, and that's why like these risky investments are so hard to predict, and why a lot of times it's not individual people that are like doing this on their own to make money. Now, some people are day traders, right? They buy a stock in the morning, they sell in the afternoon, trying to make money like just in the day. It's a long game for sure. But I think it's part of the future. I really think that crypto is it's going to be here forever. I really do. It's tricky though, because it's completely unregulated. It's untraceable, right? I don't know if you know how to like buy and sell crypto, if you've like learned about stuff like that, but you have these keys that are just these long digits of like strings of letters and numbers that like if you forget your crypto password, your money's gone. it exists digitally. Like it's not backed by anything. Like stocks are like backed by like the confidence of the company. You know what I mean? Crypto is completely just floating around space. Like it just exists virtually. And so it's hard to predict those things. You know, I see I see that question come up all the time. Is this something I should be doing? My parents called me up. They're like, should we invest in crypto? I was like, probably, but I really don't know. But you probably should. But it's just as risky as anything else, right? The thing that you don't want to ever do is put all your eggs in one basket, right? If you've got money saved up, you do not take all of that money and put it into any one thing, ever. Unless it's safe, right? Unless you have a lot of confidence that it's very low risk. But low risk usually comes with low reward, right? It goes like this, big time, right? The more risk you're willing to take, the more reward you might reap if things work out in your favor. But I could invest in Apple today and something bad happens tomorrow, like all of my money could be gone, right? And that happens all the time, right? Companies get caught for fraud, or their CEO gets arrested for whether it's a business thing or a personal thing. Like people lose confidence in companies, and that's all a stock price is consumer confidence. All it is, consumer confidence in a company. And I don't know if you guys have been following like the GameStop, AMC stock stuff that's been going on. If anybody's on Reddit, you probably hear about it all the time, but it's crazy. But it's completely like people think stocks are controlled by the companies. No, it's controlled by consumers. And they can be manipulated by consumers, right? It's so weird what happened with GameStop. Like nobody's going to GameStop, but people kept buying it, and it just became a trend on Reddit. Like let's buy GameStop. Let's watch this thing explode, and it like went up like 500% in 2 weeks. It's crazy. So a lot of different things that we can do to mess with that. Cool. Let's finish up. I'm not going to do a C. Let's just go to number 9 on that page. But I want to talk about something first, because if you look at the first question on number 9, it gives us a kind of interest rate we've never seen before, an interest rate that actually has a decimal in it already. And I want to just help you make that switch really quick, right? We're trying to make that change right there, right? From 2.5%, and I'll put it all together here for you, but and we can definitely continue this conversation for sure. I'd love to talk about all that kind of stuff. That's the thing you need to know. You have to understand how the money works in the real world if you want to make some money on your money. Clearly, my savings account is not doing that. So, like 2%, obviously, right? 0.02. Something like 3%, obviously, that's going to be like 0.03. And so, like, where does 2.5% fall? Well, somewhere in between, right? Halfway in between. And so, what do you think? That would be less. We got to be in between.
0.025.
There it is, 0.025, and here's why. Like, we don't need that 0 right there, but it's there. I don't need this 0 right there, but it's there, right? There's infinite number of zeros after every single one of these numbers. So halfway between 20 and 30 is 24. Just like halfway between 2 and 3 is 2.5. So this, for number 9, part A, that will be the rate that we decide to use there. Now, the thing about this setup for number 9 is they give us the same principle and the same number of years, but they mess with the rate and with n, right? How many times we compound per year. Let's do them together. Let's see. Now, we're going to do it, though. We're going to do it again. We're going to do with A, right? We're going to do it in terms of t first, and then we'll plug in those 3 years, okay? Same thing for B. Let's do one just in terms of t, and we'll plug in 3 years. Same thing for C. Now, I'm doing mine vertically. You probably don't have space to do them side by side. But this is eventually what my setup is going to be. And what's nice is we've got a formula that works every time. We've got to put the right numbers in the right spot. Let the calculator do the work. All right, so let's look at it. You deposit $1,600 in a bank account. find the balance. That's just how much money, right? That ending balance. How much money is in the account after 3 years, given those following situations. All right. So P 1600. Now I'm setting them all up all at once. You don't have to do this. We can just do one at a time. I'll just do this to get going. That's like, I want you to see how similar every problem is going to be. Right? Principle, whatever it is. It's not affected by anything. Here's, you walk in the door, here's $1,600. Right? That doesn't change. Doesn't matter what door you walk in. What comes right after the parentheses? 1. And since we're talking about interest, our numbers are going up. So what's going to come right after that? Plus. Now here's where everything changes. Okay. Part A. The account pays 2.5% interest. So there's my rate that's going to go up here. 0.025. 0.025. Over, let's see. R over N. Okay, the number of times we compound our interest per year. Okay, so let's see. The account pays 2.5% annual interest, compounded, there's that word that tells me I'm using this formula, monthly. So what's N if it's monthly? 12. Now, with the first version in terms of T, it's just 12T, right? Same N that was down here goes up here. And we just leave it in terms of T. But now that's actually 3 years. Now it's 12 times whatever T is, which is probably going to have to round. I don't know, but let's see what happens. Oh, I got the answer somewhere. You type it in, make sure you get the same thing that I get once I find it. Type it in, make sure you and I both get. I got $1,724.48. Yeah.
Question.
Sure.
How about typing fraction on here?
It's just division. So you would type it in like 0.025 divided by 12. Yeah. Because it's not going to look like a fraction, but fractions really just mean division. So you can just kind of write it left to right, the way we would write it up and down. Sure. Make sure you can type that in and get that same answer. If you didn't, we got to fix it. That should be good. If you got to there, then we're good. Cool with that first one? Sweet. All right, next one. I'm already set up as far as I can go, right? Same principle. 1 plus, because it's compound interest. All right, now I just got to adjust the rate. Oh, another decimal. All right. So 1.75%. Well, 1.75%. Well, all right. What's 1%?
0.1. No, 0.0.
Good. Okay. Well, look what comes after the 1. So what do you think I should put right after this? There it is. There's my rate. 0.01. So if that helps, just do like the whole percent first and then just add the numbers after that. All we're really doing is moving the decimal a couple spots. Over, all right, what do they want? Let's see. Ooh, quarterly. Good. Yeah, just 4 quarters in a dollar. It's like there's 4 quarters in a year. All right, so like the end of March, the end of June, the end of September, the end of December. That's when you do it. All right, now for T, right? Just in terms of T first, always. And tomorrow, when we build on this, and then I show you what happens as we keep increasing N, like monthly, weekly, daily, hourly, every minute, every second. You'll see kind of what direction we're headed in. We'll have a continuous compound interest formula as well. Now I can just plug in the 3. Oh, forgot to find a 0. 0. So 4 times 3, which is, make sure you can get, let's see, interest rate went down and I get paid less often. I bet this number's less. Yep. $1,686.05. Make sure you can type that in and get that. And it works. Lovely. Cool. All right. Last one, and then we'll be done. Oh, good timing too. Count pays 4%. All right, no decimals there. So what's 4% then? 0.04. 4 cents, right? $0.04 divided by, all right, so how many times we compound per year? Count pays 4% annual interest compounded yearly. How many years are there in 1 year? Just 1. I know, it's kind of like you want to say 3, right? Because it's 3 years. And that's why I try to make it like this is just per year. So I kind of actually like this question because it's a weird question to ask because it throws us off a little bit. So it's a good conversation to have. This is just like 1 times t, right? Which is why the compound interest formula doesn't make sense to really use when we're dealing with yearly. It's just the percent growth in decay formula. Because dividing by 1 doesn't change anything. So really, this is just 0.04, right? 1 plus r to the t. Now, keep the dividing by 1 if this bothers you. Keep the 1 times t up here if it bothers you. That I'm like getting rid of it, but that's the reality. Like dividing by 1. Oh, but there's got to be a 3. Sorry, to the power of 30. 4% on $1,600, 3 years in a row. Hey, at least it's a higher rate. That's pretty good. 17.9978. Oh, that is time big. Have a good day. I will see you tomorrow. Better everything be good. Thanks, everybody. Later. You are welcome. See you go. Bye. See you guys. I think at the point where you came in, it's more than halfway through, so